Hello viewers, in today's class we are going to discuss these three important integrals, right? And here we have these three definite integrals involving the greatest integer function, right? So let us first take a close look at these three integrals. Now see, in the first integral we have the limits from 0 to pi, right? And here we have 0 to 2 pi, and here we have 0 to 3 pi, right? So in the first integral, if we see here pi, then we can treat this pi as 1 pi, right? So here 1 is the natural number, and in the second case 2 is the natural number, and in the third case 3 is the natural number, right? Okay, and here the integrands are sine greatest integer of 2x over pi, right? So the integrand is of the form sine of greatest integer of 2x divided by pi, right? So whenever we come across with these type of integrals, let us see a general formula how to write directly the values of these integrals. Now in our previous videos, we have solved this integral in a detailed manner, right? And you can visit that lecture, and we have already solved this integral by the usual method of substitution, right? So now let us see the general integral. Suppose we have the integral from 0 to n pi, right? Where n is the natural number, right? So we have the limits from 0 to n pi. So here we have 0 to 1 pi. Here we have 0 to 2 pi, 0 to 3 pi. So in the first case, we have n is equal to 1. In the second case, we have n is equal to 2. And in the third case, we have n is equal to 3, right? And if we have the integrand as the sine of greatest integer of 2x over pi dx, then what is the value of this integral, right? So here we'll write the direct value. So we can write pi by 2. So the first term would be pi by 2, and then we have sine of n, right? And then we multiply sine of n by sine of 2n minus 1 over 2, and we divide this term with the sine of half, right? So this is the value of this integral. So now let us quickly write the values of these three integrals using this result. So the first one is, here we have pi by 2, and then we have n is 1. So here we have sine of 1 and sine of 2n minus 1 over 2. So this is 2 times 1 minus 1 over 2 divided by sine of half, right? So now if we simplify this expression, we get pi by 2, then we have sine of 1, and here we have 2 minus 1, that is 1. So we have sine of half divided by sine of half, right? So sine of half and sine of half get cancelled. So we are left with pi by 2 times sine of 1. So the value of this integral is pi by 2 times sine of 1. Now let us consider the second integral. So here we have pi by 2, and then we have sine of n. So sine of 2, because n is 2 here. Then we have sine of 2n minus 1 over 2. So when we take n is equal to 2 here, so we get 2 times 2 minus 1 over 2. So this is 4 minus 1 over 2, that is 3 over 2. So here we have sine 3 over 2, and in the denominator we have sine of half, right? So here the denominator is independent of n, right? Now in the third integral we have n is equal to 3. So the value is pi by 2 sine of 3, because n is 3, and then we have sine of here n is 3, so we have 2 times 3 minus 1 over 2. So this is 6 minus 1 over 2, that is 5 over 2, right? So here we have 5 over 2 divided by sine of half, right? So this is the value of this integral, right? So this is how we can solve these type of integrals using this general result.